cube all over.
Okay, I'm going to go ahead and start. The first thing I want to do is go over a few more examples and some exercises from the 3 sections that we finished, and then we're going to start the next section. My first example is you have a function s of t, and this is the function root t multiplied with 1 minus t. Now in this case, if you want to, you could apply the product rule. So to apply the product rule, think of this as the first factor, think of this as the second factor. Then by the product rule, you take the derivative of the first factor. So what's the derivative of root t? Yeah, root t means t to the half, so it'll be 1 over 2 times root t, right? Times 1 minus t, the second factor would be as it is, plus the first factor multiplied by the derivative of the second factor, which is what? -1. Everybody's okay with that? So this is what we get by applying the product rule. Everybody's okay with the derivative of root t being 1 over 2 root t, because you have t to the half, which would become half t to the negative half, right? And t to the negative half is 1 over root t. Now I'm going to redo this problem without using the product rule. So notice that if first of all, I'm going to simplify. I'm going to simplify the function in the. I'm going to multiply out. So what would I get? I would get root t minus t root t. So root t means t to the half, and t root t means what? T to the 3/2, because it's 1 plus a half. And so s prime of t, we can simply apply the power rule. Half t to the negative half minus 3/2 t to the 3/2 minus a 1, which is a positive half, right? So we could do it without using the product rule as well. The problem, if you use the product rule, then if you have to simplify the answer, then you have some more work to do. But if you don't apply the product rule, then it's easier to simplify. Or you get more simplified answer if you don't use the product rule. But either way is okay. Here's another example. Let's say I have the function y, and it is x squared plus x minus 6 divided by x cubed plus 6. Okay, x squared plus x minus 6 over x cubed plus 6. And so what would be y prime? What can I use? What should I use? Which rule should I use? We should be using the quotient rule. And so in the quotient rule, what do I have to do? I have to take the denominator and I have to square that. In the numerator, I get the denominator multiplied by the derivative of the numerator, right? So what's the derivative of the numerator? It is 2x plus 1 minus, now I get the numerator, x squared plus x minus 6 multiplied by the derivative of the denominator. Now, what is that? 3x squared. Very good. So that's the derivative that we get. Now, in the exam, if I ask you find the derivative, you don't have to multiply out and simplify this, okay? You can just leave your answer like this. Later on in the course, we will have to simplify our derivatives because we are going to do some other work with the derivative function, okay? So unless the question is, unless you have to simplify for other purpose, you don't have to simplify the derivative. You can just leave the answer right here. One warning here is that quite often I see students will write a plus instead of a minus, and also sometimes they switch the two terms in the numerator. That is, they write this one first and they write this one second. So be aware of that. So that change, if you do that, that changes your answer by a negative sign, right? So, and I hate to take off points when that happens. Okay. All right. Here is another example. Let's say I have the function f of x is 1 divided by x to the 5. So what should I do here? How do I find the derivative of this guy? Yeah, the reason I wanted to do this problem is oftentimes when I give an easy problem like this, students start to apply the quotient rule. You can apply, you are allowed to apply the quotient rule here, right? However, if you're applying the quotient rule, you're just doing a little bit more work. All you need to do is really write it as x to the negative 5, and then say this is negative 5 x to the what? Yeah, it's negative 5 minus 1, right? Negative 5 minus 1. So that will be negative 5 x to the negative 6, which is negative 5 over x to the 6. Okay? Once again, you are allowed to apply the quotient rule. There is nothing wrong with that, but I think it's a little more work than needed. Okay, next example. Let's say I have the function y, and the function y is 3x squared plus 2 root x divided by x. Okay, so how do I find the derivative of this function? Once again, I can apply the quotient rule here. You could do that. However, I won't. I am going to rewrite this as 3x squared divided by x plus 2 root x divided by x. And this is equal to then 3x plus 2. Root x means actually half divided by x, right? So it will be actually half minus 1, right? So which would be actually negative half. You guys agree with that? I have root x divided by x, right? So that means it's 1 over root x, right? And 1 over root x means 1 over x to the half, which would become x to the negative half. Is that making sense? Okay, so again, so what I was trying to say is that this quantity that I have here, that is 1 over root x because of the root x over x, and then that's the same as actually negative half. Okay. Alright, so now I can take the derivative y prime would be 3 plus 2 times, I apply the power rule, so it will be negative half x to the negative half minus 1, and this is what, 3 minus 2 cancels out, x to the negative 3 half. Okay, so that's the derivative in that case. Any questions on that? Okay, so next example, we want to find the equation of a tangent line. Okay, so let's say, and you have homework problems similar to this one. Okay, so the question is find in your next exam, you should be surprised if I don't ask you to find the equation of the tangent line at a given point by using the derivative. Okay, so find the equation of the tangent. Find the equation of the tangent line to the graph of the function y equals to root x divided by 1 plus x squared at the point 1 comma half. So what we are saying that if I look at the graph of this function, 1 comma half is a point on that graph, and you need to find the equation of the tangent at that point. Okay? Now let's check if this point is really on the graph. How do I check if this point is on the graph? I plug in 1 for x and see if y is half, right? So if I plug in 1 for x, do I get half? Okay, so then it's on the graph. Now, what is this? Remember, the equation of the tangent formula is what? Let me remind you the formula for the tangent line. Okay, so let's say I have a, oops. Let's say I have this point here. Let's say this is the graph of the function f of x. And this point that I have here, let's say that point is the point a comma f of a. Right? That's the point a comma f of a. So, and then I'm asking, hey, what's the equation of the tangent at this point? And the equation of the tangent is y minus f of a equals to the slope, and the slope at the point a is given by the what? Slope at the point a is given by the derivative of the function at a times x minus a. So that's the equation of the tangent line, right? Everybody's okay because the slope is given by f prime of a, and we have a point a f of a. Now in our case, what is f of x? In our case, f of x is root x over 1 plus x squared. So in order to find the slope at the of the tangent at the point 1 half, I have to find the derivative. So what's the derivative? Well, we apply the quotient rule. By the quotient rule, this would be 1 plus x squared, right? Okay, in the numerator, the first term is the denominator multiplied by the derivative of the numerator. What's the derivative of the numerator? It is root x, right? Okay, half, and then 1 over 2 root x, right? That's the derivative of root x. And then minus the numerator multiplied by the derivative of the denominator. And what's the derivative of the denominator? 2x. Okay? Now, you can take time to simplify this out, but you can find, so what we need to do is find the value of the derivative at 1, right? Because we want the slope of the tangent at 1, right? Everybody is right? Okay. So now, I don't have to simplify the derivative. I can just plug in 1 for x and find out exactly what f prime of 1 is, okay? So if I plug in 1, what do I get? I'm going to get 1 plus 1 squared, right? Which would be what? Which would be 2 times 1 over what? Because of root of 1 is 1, right? Minus, I get root of 1 is 1, and then 2 times 1, so that's just 2. In the denominator, I am going to get 1 plus 1 squared, which would be 2 squared, right? Are we okay with that? You plug in 1 for x, you get 1 plus 1 squared, which is 2. And then 1 over 2 root x would be 1 over 2 root 1, which would be 1 half. So what do I have? I get negative 1/4. So notice that I didn't have to simplify the derivative to find out the value of f prime at 1, right? So that's the slope of the tangent at 1, right? So now I'm given the point, right? 1 comma half, right? So what's the slope is given by this. That's the slope. That's the slope of the tangent, and the tangent line goes through the point. What point? The given point is what? 1 comma half, right? So the tangent line goes through this point. It has slope negative 1/4. So I use the slope intercept formula. What is that? No, you have to use a point slope formula, which is y minus what? Y minus half equals to negative 1/4 x minus 1, right? You have to use the point slope formula because here you are not given the y-intercept. Okay, so that's the equation of the tangent line. You can leave your answer here. You don't have to simplify it anymore, okay? So this is good. Everybody understood that problem. In your homework, you have similar problems that you need to practice. Like I said, I would be very surprised if I don't put it on the exam. Okay. I think I have done enough problems from these three sections that we finished yesterday. The next thing that I want to do is go over a very important derivative formula, which is called the chain rule. And this is section 2.5. Okay. And we finished up to section 2.3. Section 2.4 we will cover after we are done with 2.5. Okay. So here is the chain rule. The chain rule is about finding the derivative of the composition of two functions. Suppose you know the derivative of f, suppose you know the derivative of g, then how would you find the derivative of the composition of f and g? So let me start with an example to motivate why do we need this rule. Let's think about this simple function that I have, x squared plus x minus 1 to the exponent 5. How would you find the derivative of this function? If I ask you find the derivative of this function right now, what would you do? What would you do? If you know the chain rule already, forget it. Just tell yourself you don't know the chain rule. How would you do this problem with, right now with what we have learned so far? You just multiply it out and write everything in terms of powers of x, and then you apply the power rule, right? Well, 5 is pretty encouraging, right, for you to do. Yeah, we can do it, 5. So let me make it 50. Do you want to do it still? You feel courageous enough to do it now? Okay. My point is, to find the derivative of this guy, you know, if you can ask a computer to do it, but we could find the derivative of this guy by using what we call the chain rule much easier. So notice that this function that I have, it's the composition of two different functions. Okay. First of all, what is the outside function of this composition? X to the power 50. That would be the outside function, and the inside function of the composition would be x squared plus x minus 1. Let me see. Let's call this g, right? Okay, let's call the g of x, and let's call this h of x. And then let's check if we are correct. What is g of h of x? G of h of x is g of x squared plus x minus 1, and then g of that is x squared plus x minus 1 to the 50, right? So indeed, the function f is the composition of g and h. G is the outside, h is the inside. And so it turns out that the derivative of f can be found in the following way. The derivative of f, you take the derivative of the outside function. What's the derivative of the outside function? Here, outside is x to the 50, right? What's the derivative of x to the 50? 50 times, I'm not going to write x yet, 50 times x to the 50 minus 1, right? 50 minus 1. So I should be putting x here, right? That's the derivative of the outside, but instead of writing x, you have to put in the inside, okay? X squared plus x minus 1. And then you have to multiply by the derivative of the inside, h prime, which is what? Which is 2x plus 1. So it turns out that the derivative of this function is given by this. So you sort of like, my high school teacher used to say that you have a giant to the 50, you take the derivative of the giant to the 50, it's 50 times giant to the 50 minus 1, and then multiply by the derivative of the giant. Okay? So generally, what is the chain rule? So the chain rule is the following. So you're trying to take the derivative of the composition of two functions, f of g of x, and the derivative of the composition is given by, you take the derivative of the outside function, Okay, you take the derivative of the outside function, but you have to evaluate the derivative of the outside at the inside, and then you multiply by the derivative of the inside function. So this is the chain rule formula. Okay, go up, yeah. Okay, is everybody doing okay with this formula, what this is saying? We're going to go over lots of examples of that. We're going to go over a lot of examples of this. So this is the chain rule. Okay, let me highlight this. So this is the chain rule. And let's go over examples until you tell me that you are feeling comfy about the chain rule. Okay. All right. So example. Let's say I have the function. Y equals to root of 5x plus 7. Okay. 5x plus 7. So I want to find the derivative of y, right? Notice that there is nothing you learned so far that will help you find the derivative of this, but the only thing you can apply is the chain rule. Notice that this function is 5x plus 7 to the power half, right? And if I had, you have that 5x plus 7 there, you desire that 5x plus 7 is just x, right? Then you can apply the power rule, right? If that 5x plus 7 was just x, you could find the derivative right away, but you have that 5x plus 7 there. So then you say, well, this is the composition of two functions, right? What's the outside of the composition here? X to the power half, that's the outside of the composition. And then what's the inside? 5x plus 7. So by using the chain rule, you take the derivative of the outside. What is that? The derivative of the outside is what? Half x to the half minus 1, right? I should be having an x here. Half x to the half minus 1. But instead of x, I have to put in the inside there. The inside of the function there. Okay? And then I multiply by the derivative of the inside, which is what? Which is 5. Is everybody okay with that? Okay, no, my answer is right here, okay? You could simplify this a little bit by writing exponent negative half and then write half times 5 as 5 half. Okay? Is everybody doing okay with that example? Okay, so let's look at another one. Let's say I have the function f of x is sine, oops, what am I saying? Sorry, we haven't talked about the derivatives of the trig functions yet. So let me try to choose some other functions. Okay. Let's say I have the function f of x is x minus 1 divided by x plus 1, and then we take the root of that function. Okay. And we want to find the derivative of this. Now, it's the composition of what functions now? This is the composition of what would be the outside of the composition? Say it again. Actually, I could say, let me first of all write this as x minus 1 over x plus 1 to to the power half, right? So I can say that the outside is actually half, inside is x minus 1 over x plus 1, right? Okay, so then by the chain rule, I could say that the derivative of the outside is, we have seen this, half times x to the half minus a 1, right? But instead of x, what should go there? X minus 1 over x plus 1, that's the inside. And then we multiply by the derivative of the inside, right? I take the derivative of x minus 1 over x plus 1. But it's not easy. I have to apply what? Half x minus 1 over x plus 1 to the negative half. And the derivative of the inside, I have to apply the quotient rule. So I get what? X plus 1 squared. And then here I get x plus 1 multiplied by the derivative of x minus 1, which is 1, right? Minus x minus 1 multiplied by the derivative of the denominator, which is 1. Is everybody okay? So what is that? This is actually one of the questions that I asked last time I taught this course in the exam. So this is this, and then in the numerator, x cancels out, and then I have 2, right? And I mean, if you want to simplify this, you don't have to simplify. The only question is to find the derivative. But I'm going to go ahead and simplify this. 2 and 2 cancels out here. What I have here, you see, x minus 1 over x plus 1 to the negative half. If I want to make that a positive half, what should I do? I have to flip it, right? So I will get x plus 1 over x minus 1 to the power half multiplied by 1 over x plus 1 squared, and this would be x plus 1 to the half over x minus 1 to the half times x plus 1 squared. And then I can combine the x plus 1 terms as what? Can I write it as 1 over x minus 1 to the half times 1 over x plus 1 to the 2 minus half, right? What is that? Can I do that? Which line? Well, you have x plus 1 squared here, x plus 1 to the half. So you can combine them as 1 over x plus 1 to the power 2 minus half. If you have a to the m divided by a to the n, what is that? I can write this as a to the n minus m. Right. Okay, so that's the final answer. Did you guys need that to write it down? Okay. Did the use of chain rule make sense? You guys are doing okay with that? Okay. All right. So once again, the chain rule that we have is basically written as d dx of f of g of x is f prime at g of x times g prime of x. Now, sometimes the chain rule is written in a different form. If z represents the value of the function f of y, and y represents the inside function g of x, so f represents the outside, g represents the inside, then notice that I can think of z as f of g of x, right? And then I can say that the derivative of z with respect to x would be, derivative of z with respect to x would be by the chain rule. This is what? F prime of g of x, right? Times g prime of x, right? dz dx means it's the derivative of z with respect to x. What is z in terms of x? F of g of x, right? And notice that this means I have f prime of y times g prime of x, right? But what is f prime of y? Can I say this is dz dy? That's another symbol for the derivative of f with respect to y. And then what is g prime of x? I can say this is dy dx, right? Is everybody okay with that? So then I can write dz dx to be dz dy times dy dx. Now when I write the symbol dz dy, right, I don't mean arithmetic division, right? It's just a symbol. It says you're taking the derivative of z with respect to x or with respect to y. Okay? So once again, what's going on here, sometimes you might have that y is a function of x, and then you might have that z is a function of y, right? Z is a function of y and y is a function of x. Then z is also a function of x via y, okay? Z is a function of x via y. Then the question is, what's the derivative of z with respect to x? Well, the derivative of z with respect to x is derivative of z with respect to y multiplied by the derivative of y with respect to x. You might say, why do we bother that? Well, sometimes, you know, maybe you can find the derivative of z with respect to y. Maybe you are given a formula for z in terms of y. You're given a formula for y in terms of x, but you don't have a formula for z in terms of x directly. So you can use this to find the derivative of z with respect to x. Am I making sense? Z is a function of y, y is a function of x. So z is a function of x via y. Then you can find the derivative of z with respect to x by using the formula dz dy times dy dx. The easiest way to remember this formula is that think of this as fractions and you're canceling out dy's, right? But of course, that symbol doesn't mean arithmetic division, right? Is everybody okay? So this is another form of the chain rule. Because here, when I have z is a function of y, y is a function of x, z is a function of x via the composition of the two functions, right? This is a function here, another function here, and then z is a function of x. That's the composition function, okay? Am I making sense? I mean, think of this as f of y. Think of this as g of x. Then this guy, this is the function f of g of x. Okay. So this is really the chain rule, but it's just written differently. Is this formula making sense to you? In engineering classes, if you use the chain rule, usually this is the form you use. In physics, if they usually use this form of the chain rule. Okay. The proof, I gave you the proof. You have the chain rule. Well, I didn't give you the proof of the chain rule, but this is the chain rule that we have. This is the chain rule, and then you can. That's what I showed you, that if you use that chain rule, you get dz dx to be dz dy times dy dx. You don't have to know how you get it. You mean the proof of the chain rule? You don't have to know the proof of the chain rule. What's that? You have to remember this formula here. Yeah. You have to remember these two formulas, okay? Okay, let's look at some examples. Let's say you're given that z is root of y, and you're given that y is x squared plus x plus 1. Excuse me. So what's the derivative? So then you're asked to find dz dx. So what's the derivative of z with respect to x? Well, we know that dz dx is the same as the derivative of z with respect to y times derivative of y with respect to x. Now, because I have the formula for z in terms of y, what is that? Yeah, the derivative of root of y, so that would be 1 over 2 root y times dy dx would be what? 2x plus 1. Okay. And then you can plug in the value of y. Remember, y was x squared plus x plus 1. This would be 1 over 2 times x squared plus x plus 1 times 2x plus 1. Okay? Is everybody doing okay? I mean, what you really found is the derivative of this composition, okay? If I look at the function x squared plus x plus 1, and if I look at the root of that, if I look at the root of this function, we actually found the derivative of that function. Because what is the function z as a function of x? Z as a function of x is the composition of the two functions. Okay? So z as a function of x is really root of x squared plus x plus 1, and we are using the chain rule to find the derivative of that. You'll see that if you find the derivative of this guy by using the first form of the chain rule, you get this. Now, if I do it this way, I also get the same answer. Is that making sense? Everybody's okay with that? Do you have any questions on that? Okay, another example. Let's say I have the function y, and it's given to be 2x plus 1 to the power 5 times, let me just say to the power 5. What's the derivative here? Now, if I want to use the second form of the chain rule, I could say take z to be, oh, I'm using y here, right? Am I? Sorry. Let me use a different symbol here. Let me say this is capital F of x. I can use the chain rule here as I did in my previous examples before I showed you the second form of the chain rule. But I want to show you how I can use the second form of the chain rule here. I can say, well, let's let z to be y to the 5, okay? So I am basically substituting 2x plus 1 by y. And then I'm taking y to be 2x plus 1, right? So y is 2x plus 1, z is y to the 5. So then, if you look at f prime of x is basically dz dx, okay? Right? Because z as a function of x, that's just the composition of y to the 5 and 2x plus 1, right? Am I making sense? So what is that? Well, this is dz dy times dy dx, and this is equal to, what is dz dy? It's 5 y to the 4, and dy dx is what? 2. And then this is 10 times y to the 4. And what is y? 10 times 2x plus 1 to the 4. Notice that if you did it by using the first form, you would have got the same answer, right? You realize that? Now, I'm not asking you to use one form over the other one. I'm just making you aware of both forms. Because as I said, usually in engineering and physics they use the second form, okay? Go up.
Can you explain what you did? Because that form always confuses me.
This one here?
Yeah.
Well, I have to take the derivative of this function, right?
Correct.
So what I'm saying is let this guy to be y.
Okay.
So I'm substituting y for this, and then z is y to the 5. So then, if I want to find the derivative of this guy, it's the same as finding the derivative of z with respect to x. Okay? The reason is, if you take the composition of these two functions, right? So what is z? Z is basically, you replace y by this, right? Z is the same as that, right? So if I take the derivative of z with respect to x, that's the same as f prime of x.
Yeah.
Because z is equal to 2x plus 1 to the 5. So what is dz dx? Well, dz dx by my second form of the chain rule is dz dy times dy dx. Okay?
Okay, so the derivative of y.
Derivative of z with respect to y is 5y to the 4. Derivative of y with respect to x is just 2 by the power rule. And then at the end I am replacing y with 2x plus 1 again.
Okay.
Okay. Is that making sense? Any other questions? You guys realize that z as a function of x is the same as f of x, right? Because y is 2x plus 1. So if I plug in 2x plus 1 here, z is 2x plus 1 to the 5. Exactly the same as f of x. Z as a function of x is the same as capital F of x, right? So the derivative of capital F of x is the same as dz dx. But what is dz dx? It's dz dy times dy dx. and then I just compute those and plug them in. Yeah.
So, how do you go from you plug in the derivative at the top? I see that. But then what about the bottom? What about the dy and the dx at the bottom?
Right here?
Yeah.
dy dx represents the derivative of y with respect to x, right?
Okay.
So what's the derivative of this guy with respect to x? It's just 2 times the derivative of x, which is 1.
Right.
Plus the derivative of 1, which is 0, so you get 2.
Okay.
Right? This is not in the denominator, right? You're multiplying this with this.
Okay.
I'm not sure what.
I understand now. Since
Yeah.
you
Yeah.
since you did that.
Okay. I wasn't sure exactly what you said. I was just trying to answer something that I thought you were asking.
Yeah,
Okay.
it makes sense.
Again, if you think about the first form of the chain rule, wouldn't you say that this is the outside and this is the inside? So you take the derivative of the outside, multiply by the derivative of the inside. Am I making sense? We are just denoting the inside by y. We are denoting the outside function by z, right? Am I making sense? So if you apply the first form, you get derivative of the outside, which is here, multiplied by the derivative of the inside, which is here. Am I making sense? Okay. Let's see. Let's do one more practice with the chain rule. Suppose I have y equals to 2x plus 1 to the 5, and then I have root of x squared plus 1. Now, in this case, I cannot apply the chain rule directly. What I have to do, though, is first of all think of this as the product of two factors, and I have to apply the product rule first. So, by using the product rule, what do I have? By using the product rule, I will have to write what? I'm going to write out exactly what the product rule says first. The product rule says this will be, you take the derivative of the first factor, right? You take the derivative of the first factor, you multiply by that by the second factor as it is, plus you have the first factor as it is, multiply by the derivative of the second factor. Are we okay with that? That's the product rule, right? Yeah. What do you mean top rule? No. No, in the numerator you get negative in the middle. Plus it has to come in a specific order. It's the derivative of, it's the denominator times the derivative of the numerator minus. So there is a specific order in which they have to come. Here it doesn't matter whether I write this one first or this one first. Okay. Now we are going to apply the chain rule, right? So if in the first derivative that I have 2x plus 1 to the 5. So what's the outside? Something to the power 5, right? So the derivative of that is 5 times that something 2x plus 1 to the 4, and then you multiply by the derivative of the inside, which is 2, and then you still have that x squared plus 1. For the second one, you have 2x plus 1 to the 5. Now, x squared plus, you have the root of x squared plus 1, right? So what is that? That is x squared plus 1 to the power half, right? That's what you have right here. And so what's the derivative then by using the chain rule? Someone. What's the outside? Outside is something to the power half. Yeah, so actually, what's the derivative of that? Half times x to the half minus 1, which is negative half. So instead of x, what did you write? What did you write here? The inside, right? X squared plus 1. And then you multiply by what? Multiply by what? 2x. Because that's the derivative of the inside x squared plus 1. Okay? Is everybody okay? So I have x squared plus 1 to the half. So this is like having actually half. The derivative of that is half, actually half minus 1. And then instead of x, you put in this guy. And then the derivative of the inside is 2x. Is everybody doing okay with that? Alright, so if you want to simplify a little bit, you could. This is 10 2x plus 1 to the 4 root of x squared plus 1 plus this would be 2 cancels out. Notice that what I am getting is x times 2x plus 1 to the 5 times x squared plus 1 to the negative half. Okay, you don't have to simplify anymore, but I am going to show you how to, if you have to simplify this, how would you simplify this? What you need to do is factor out as much as you can. So what I'm going to do here, okay, your answer is done right here, okay? But I'm going to show you how to simplify this further, because sometimes you might need that in some other problems. So what you need to do is you have to factor out as much as you can. So I see that I can factor out 2x plus 1 to the 4. And I'm also going to factor out the negative x squared plus 1 to the negative half. Okay? So when you factor out, what do you do? You divide each term by that, right? So what am I going to get from the first?
Wait.
Yeah.
Why you got x to the negative half?
I'm factoring that out. I am factoring out 2x plus 1 to the 4 and x squared plus 1 to the negative half. So let me ask you the following. If I factor out, suppose I have 4 plus 9, right? And if I want to factor out, let's say 3, right? What do I get? I divide each term by 3, right? So I get 4 over 3 plus 9 over 3 is 3, right? Factoring out means you divide each term by that, what you're factoring out. So same way, if I am factoring out, what I have to do is divide this guy by what I factored out. So if I divide this by what I factored out, what would I get? Notice that 2x plus 1 to the 4 will cancel out, right? When I divide, I am dividing this by this, right? So this will cancel out. I'm going to have a 10, right? Now, what happens when you divide the root x squared plus 1 by this? This is x squared plus 1 to the power half. This is x squared plus 1 to the negative half. What did you get? Just to the 1. Very good. So this is really x squared plus 1. Again, you are dividing x squared plus 1 to the half, right? Let me write it on the board. X squared plus 1 to the half over x squared plus 1 to the negative half, right? So when you divide, you subtract the exponents, right? So this would be x squared plus 1 to the half minus half, right? You subtract, because you have division, you subtract the exponent, so you get 1. Now what happens on the second term? Well, in the second term, I'm going to have x times 2x plus 1 remaining. Let's see if you agree with that. You guys agree with that? When I divide this by this, 2x plus 1 to the 4 and 2x plus 1 to the 5 will give me 2x plus 1. This x will remain, and then this guy and this guy will be cancelled out. Right? Okay, so then this is what I get now, 2x plus 1 to the 4 over x squared plus 1 to the half, and in the brackets I get 10x squared. You notice that I have a 10x squared here and I have 2x squared here, right? So that will be what? 12x squared. 12, well, let me just not be lazy here, let's just multiply out. So 10 x squared plus 10 plus 2x squared plus x. Am I okay there? So this would be 2x plus 1 to the 4 divided by x squared plus 1 to the half, 2x plus 1 to the 4, and what do I have now? 12x squared plus x plus 10, right? Was that?
That's too much extra.
Oh, algebra, yes. Like I said, if I ask you only the derivative, then your answer was done way before, okay? But sometimes this is what you need to do. Sometimes you have to find out where the derivative is 0 in some problems. Now, if I ask you that for this problem, if I ask you where the derivative is 0, unless you simplify, you wouldn't be able to find that out. So if I ask you where the derivative is 0, then you say, well, this guy is 0 when either this guy is 0 or this guy is 0, right? Can I solve where this guy is 0? Yeah, 2x plus 1 is 0 when x is negative half. Can I find out where this guy is 0? Yes, you just use the quadratic formula, right? So if you have to find where the derivative is 0, then this is what you need. Alright, in any case, so that's how you could simplify, and you would have to do it in the later sections, okay? All right, any questions, anybody? Any questions at all? No? You guys need a break at this point, or should we take the break a little bit later? A little bit later? Okay. All right, we are done with 2.5, but I will be doing more examples from that sections once I finish 2.4, okay? So now we look at, in section 2.4, now what I want to know is the derivatives of the trig functions, okay? Once again, trig functions, a lot of the students in Calc 1, they keep trying to avoid trig functions, and then the more they try to avoid trig functions, the more they find out that they cannot avoid trig functions, okay? When you go to Calculus 2, some of you said you're going to take Calculus 2. If you don't make friends with the trig functions, you will be in trouble, okay? So what we want to do now, we looked at the trig functions, sine x, cosine x, and the other trig functions. Now we want to know what are the derivatives of those functions, okay? So so now the topic is the derivatives of trigonometric functions. Okay, so in order to find if I want to find the derivative of the sine function, right, I have to apply the limit definition and compute that limit. And in order to compute that limit form of the derivative of sine, I have to know a couple of limits. Now, the number one limit that you need to know is that what's the limit as theta goes to 0 of sine theta divided by theta. I have already told you this limit before. What was the limit? I told you that this limit was 1. The only explanation I gave you was that I showed you how the graph of this function looks like near 0. But then I told you that that's cheating, because in order to come up with the graph, you need to know what this limit is beforehand. Okay. Now, how do anyone know what this limit is without looking at the graph of this function? And so that's what I want to do in here. But before that, let me write down another limit that we need to know, which is the limit as theta goes to 0 of cosine theta minus 1 divided by theta. And it turns out that the first limit is 1, and then the second limit is 0. Okay. And let me justify why the second limit is 0 first. So if I look at the limit as theta goes to 0 of cosine theta minus 1 over theta, in order to compute this limit, the trick is something like rationalizing. You multiply and divide by cosine theta plus 1 over cosine theta plus 1. If you do that, then what did you get? You get the limit as theta goes to 0. Remember, whenever we rationalized, we didn't multiply out the denominators, right? So here I'm going to write theta times cosine theta plus 1. And in the numerator, I am going to multiply out. If I multiply out in the numerator, what do I get? Cosine squared of theta minus 1. Is that all I get? You can use FOIL to multiply out, right? You're going to get cosine squared minus 1. What are the other two terms? Other two terms are cosine theta and negative cosine theta, right? And they cancel out if I use FOIL, right? Okay, now cosine squared minus 1, what can I replace that with? Any trig identity that I can apply there? Well, we just had that. We multiplied them out, right? Yes, so remember we have this cosine squared theta plus sine squared theta is 1, right? So from that, what is cosine squared theta minus 1? It's negative sine squared, right? Am I right? So I can replace the numerator by negative sine squared of theta. Is everybody okay with that? Well, we're going to see in a bit. Okay, we're not done yet. So this is now equal to the limit as theta goes to 0. We're going to write this as negative, and then I'm going to write it as sine theta over theta times sine theta over cosine theta plus 1. And now we can say what the limit is. Now, in order to find this limit, I have to use the first one. I haven't showed you why the first limit is 1, but in limit number 2, we're going to use that. So I know that sine theta over theta goes where? We know that this guy has limit, this guy goes to limit 1. What is happening to this guy? Notice that as theta goes to 0, in the denominator 1 plus cosine theta is what? It goes to 2, right? And so the denominator here goes to 2, the numerator goes to where? Sine 0 is 0, right? So the ratio goes where? 0. So I know that I get negative 1 times 0, which is 0. Okay, so the limit is 0. That's how we get that limit is 0. We are going to use this fact in later to compute the derivative of the sine function. Okay, is everybody okay with that? The limit of the ratio, because we know that sine and 1 plus cosine theta, these are all continuous functions. So if I take the limit of this, the limit of the numerator is 0, the limit of the denominator is 2, so the limit of the ratio would be 0, right? Okay, so that's the first, that's the second limit that we computed. So the second limit, the limit of cosine theta minus 1 over theta as theta goes to 0 is 0, and in order to find that limit, we used number 1. Okay. Now the question is, how do you know that the limit of the first one is 1? Well, for that we have to do a lot of work. Let's say I have this circle. Whoa. Let's say that's the unit circle. X-axis and let's say that's the y-axis. Okay, so let's say I have the angle theta like this. So this is the angle theta right here. Okay, and from the point, from the intersection of the terminal side of theta and the circle, I'm going to make a line segment like this. And also, I am going to make a line segment starting from here up to this point. Let's label this point as this is O. Let's say this is let's say, well, let me use Q for this guy and P for this point here. Let's use R for this point here, and how about this point here? Let's just say Q prime, okay? Okay, so we need to find the limit as theta goes to 0 of sine theta over theta. And the problem with this is that this is not an usual algebraic trick you do and then you find the limit. In order to obtain this, you have to use this geometry, okay? Can someone tell me what's the... Okay, this is the unit circle, okay? So the point Q that I have here, that point is the point 1, 0, okay? Because it's the unit circle. What's the length of OP? What's the length of OP? 1, because it's the unit circle, it's the radius. Can someone tell me what's the area of OPR? What's the area of the triangle OPR? In general, the area of a triangle is what? Half times base times height, right? So what is this length? Half times the length of OR, right? The length of OR. I'm going to use this symbol to signify the length of OR. And then what's the length of the oh, you know what? I made a terrible mistake here. I'm sorry. That PR that I drew there, I didn't want to draw it the way I did it. Okay. Sorry about that. Let me change that. Can I highlight 1 minute? Let me erase this. Not that big. What I wanted to do is add the points here. Yes. So I don't even need this R here anymore. Don't need that. Okay, now what I want to ask is, what's the area of the triangle OPQ? Okay, OPQ. If I want to find the length, well, actually, I do still need this height. Okay, what's the area of the triangle OPQ? I do need that R, sorry. What's the area of the triangle OPQ? It'll be the length of half times the length of OQ, and then the length of PR, right? PR is the height, right? Base is OQ. Do you agree with that? Is everybody okay with that? The area of the triangle OPQ, half times base times height. So the base is OQ, the height is PR. Now, that would be less than, you guys can see the area of the sector like a pie, the pizza piece right here. The area of the sector OPQ. What's the area of the sector OPQ? Anyone knows that? What's the area of the sector OPQ? The sector OPQ. So this is the sector. Okay. So what is the area of that sector? Well, what's the area of the entire? What's the area of the entire disk? Pi r squared, right? Pi r squared. So when theta is 2 pi, right? When theta is 2 pi, that sector will have area pi r squared. But theta is not 2 pi, right? So I have to divide this by, multiply this guy by what? Theta over 2 pi, right? If theta were 2 pi, then the area would be pi r squared. So the area of the sector OPQ would be theta over 2 pi times that. Now, the last thing, what's the area of OQ prime Q? What's the area of OQ prime Q? That's half times the length of OQ, right? Times the length of what? Q prime. Okay, what's the length of OQ? The length of OQ is what? That's the radius of the circle, right? OQ is the radius, so I get 1 for that. Notice that I have a 2 in the denominator in each side, right? They cancel out, so I can multiply everything by 2. If I multiply everything by 2, these 2, and these 2 will cancel out. So multiply everything by 2. And OQ will become 1. So this is on the far left, I get just the length of PR less than or equal to. Here I get simply pi cancels out, so I get r squared. Oh, what is r in this case? 1. So all I get really is theta. And then here half and OQ goes away, I get the length of Q prime. Now, you might be saying, hey, I thought we are trying to find the limit of sine theta over theta. Where is sine theta over theta? Yeah.
Where did r squared go?
The radius of the circle is 1. Yeah. This is the unit circle. Now, can someone express the length PR in terms of sine function? Okay, in the triangle OPR, that's the right triangle, right? In that triangle, what is PR divided by the hypotenuse? What is the length of the hypotenuse here? 1, right? So what is PR divided by the hypotenuse? 1. Isn't that sine theta opposite over the hypotenuse? That's sine theta, right? So I get that PR is exactly sine theta. So less than or equal to theta. What is Q prime? If you look at the triangle OQ prime, right? What is Q? What is Q prime divided by OQ? What is that? What is that ratio? Q prime divided by OQ. What is that ratio? No. That's in the triangle OQ prime, right? The opposite is QQ prime. The adjacent is OQ, right? So, yeah. Oh, OQ in the denominator. In the denominator, OQ. Yeah. So that's what I want there. So QQ prime. So that's tangent theta. Yeah. So that should be OQ. Tangent theta. So then I can have this is less than tangent theta, because OQ is just 1, right? OQ is just 1. Okay, now I'm going to rewrite this as sine theta less than or equal to theta less than or equal to tangent is sine theta over cosine theta. Is everybody okay with that? Everybody's all right? Okay, now what I want to do is divide everything by sine theta. Okay? So if I divide the left far side by sine theta, I get 1. Here I get theta over sine theta. And here I get 1 over cosine theta remaining, right? If I divide by sine theta. So what is that? I get, okay, now what I'm going to do is I'm going to flip everything, okay? If I flip everything, what do I get? In the middle one would be sine theta over theta, right? But if I flip, the inequalities would be what? Reversed, right? And this would be what? Cosine theta. So what I have is cosine theta less than sine theta over theta less than or equal to 1. Now we apply the sandwich theorem, okay? What's the limit as theta goes to 0 of 1? Obviously this guy has limit 1 when theta goes to 0. What's the limit of this guy when theta goes to 0? Cosine 0 is 1. So what's the limit of the middle one? The limit as theta goes to 0 of the middle one is 1. Okay, do you have to reproduce that in the exam? No. You just have to remember that the limit of sine theta over theta is 1. Okay. Alright, so that's how you obtain this limit of sine theta over theta is 1. Okay. Any questions, anybody? Okay. Alright, so now we want to see how we could use these limits in order to compute the limit or the derivative of the sine function and the cosine function. But before I do that, I want to show you some examples of using these two limits, okay? Suppose that I have to find the limit as x goes to 0 of sine of 7x divided by 4x. How would you find this limit? How would you find this limit? The only remember we just showed that the limit as theta goes to 0 of sine theta divided by theta is 1. In order to apply this, though, you have to see that the angle is the same, right? The angle theta and the denominator quantity are the same. So if I want to use that here, I have to make sure that in the denominator I have the same angle as in the numerator. Oops, what am I writing here? Sometimes this is so slow. Okay, so I have the limit as x going to 0. I am going to rewrite this as sine 7x. Sine 7x divided by, I want to have 7x if I want to apply the limit sine theta over theta. So I want to have 7x, but I don't really have 7x, right? I didn't have 7x, I had 4. I didn't have 7 in the denominator, I had 4. So what should I do? But I want to have 7x there. Well, I should write this, right? If I have that, then I still have sine 7x over 4x, right? Everybody's okay? Now,
Can you do that without skipping this step?
can I do that without skipping that step?
Like put 4 back, or put 4 back and then multiply what you need to get 4 in.
Well, yeah, so basically I'm saying that in order to use this, I have to have the same angles here. So I want to have 7x here.
Yeah.
And now I see how I can adjust it so that I still have just 4x here.
Oh, okay. Now,
So I'm saying that when I... Yeah.
7 against
Yeah, yeah. And then now I could say that the limit of the limit of this guy is 1, and then I have 7/4 to multiply out with. So the limit is 7/4. Is everybody okay with that? The usual mistake people make here is that they say, well, as x goes to 0, this guy goes to 0, this guy goes to 0. So they interpret this by saying that here theta goes to 0, here denominator goes to here, so this will go to 1. So when they interpret it that way, they say, well, this guy goes to 0, this guy goes to 0, so sine of something going to 0 divided by something going to 0 is 1. Okay, they will say the answer is 1, and that's the wrong answer. Okay, is everybody okay? You have to make sure that both of them go to 0, but they are just equally going to 0. They are equal. Okay. You know, if I have 7x and 4x, which one goes to 0 faster? One of them goes to 0 faster, right? Okay. Another example. Say I have to find the limit as x going to 0, x times cotangent of x. How would you find this limit? How would you find this limit? Yeah.
Oh, well, cotangent equals cosine over sine.
Very good. So, again, in trigonometry, very often you have to convert everything to sine and cosine, right? So this would be cosine x divided by sine x. That's pretty good. Now, if I want to use the two limits that I gave you, right? I gave you the two limits at the beginning, 1 and 2. If I want to use one of those or both, what should I do here? Now, how should I rewrite this? How should I rewrite this? X over sine x, very good, times cosine x. Now you might say, hey, we just knew that the derivative, the limit of sine x over x as x goes to 0 is 1, right? We know only this. We know this, right? Sine theta over theta goes to 1 when theta goes to 0.
Does that mean that's negative 1?
No, if you flip it, it still goes to 1, right? The reason is, well, if you don't believe that, let's just say x over sine x. Can't I just write it? In general, if a quantity goes to 1, then its reciprocal also goes to 1. In general.
Oh.
Okay? And notice that x over sine x, isn't that the same as 1 divided by sine x over x? It's just the reciprocal of sine x over x, right? X over sine x, that's the reciprocal of sine x over x, right? Well, now, what's the limit of sine x over x? 1. What's the limit of cosine x? 1. Altogether, the limit is 1. Is everybody okay with that? Any questions, anyone? Okay. Everybody's okay? All right. Now, in your homework from this section, you'll see that you have some limit questions. You have to use the limit 1 and 2 that I gave you. You have to use those limits and compute those limits in the exercises. Okay, so keep that in mind. All right. Now I'm going to talk about how do I find the limit, the derivative of the sine function. Okay. So I want to find the derivative of the function sine theta, okay, sine x, okay. So let me say, let's let f of x to be sine x. And so then, what would be the derivative of what would be f prime of x? What's the limit definition of f prime of x? Obviously, I don't have a formula for sine x because that's what I'm trying to do. I'm trying to find a formula for the derivative of sine x. So what's the derivative of f? What is f prime of x? Well, it is limit h goes to 0, f of x plus h minus f of x divided by h, right? Everybody's okay? One way to remember this ratio, sometimes if you're having a hard time remembering this ratio, think about this. You have x, you change x to x plus h. You have x, change it by a little bit, x plus h. Then this is the difference of, this is the change of f values, right? F of x plus h minus f of x. This is the change in x, right? Change x from x to x plus h. So change of f over change of x, okay? Now, what is that? Well, this is the limit as h goes to 0. What is f of x plus h here? Sine of x plus what? X plus h minus f of x is sine x divided by h. Well, now I'm stuck, right? What to do? What should I do? How do you compute this limit? How do you compute this limit? Let's see how much experience you have with trig. So you see that sine of x plus h. If you have no other clue, you say, well, let me just try to apply the sum formula for the sine function and see what happens. So that's what we're going to do. We are going to apply the sum formula for the sine function. And how many of you remember that? Sine of x, sine of a plus b. What is that? Sine a, so sine x times cosine h, right? Plus sine h cosine x minus sine x. So that's the sine, the sum formula for sine, and whoops. So this is equal to the limit as h goes to 0. What should I do now? Well, what I'm going to do is combine the first one with the second, with the third one, and factor out the sine. So what am I going to get? If I factor out the sine x, what do I get? Cosine h minus 1, and the other term I'm going to keep it as it is, sine h cosine x over h. Are we okay with that? Now I'm going to rewrite this as the limit h goes to 0. I am going to write it as sine x times cosine h minus 1 divided by h plus sine h divided by h cosine x. Can I do that? So I'm just taking this guy divided by h, this guy divided by h separately. Now the limits 1 and 2 says what? What is the limit of this guy? And what is the limit of this guy? The first one is 0, right? Cosine theta minus 1 over theta goes to 0 when theta goes to 0, right? So instead of theta you have h. This is going to 0 and this is going to 1. So what am I left with? I am left with just cosine x, right? I am left with cosine x. Is that right? What's that? It's sine x times 0, right? The limit of the ratio is 0. This guy is going to 0, so sine x times 0. This guy is going to 1, so 1 times cosine x.
Why is there going to 0 again?
That's limit number 2. If you look at number 2, that's limit number 2. Limit number 2 was cosine theta minus 1 over theta goes to 0 if theta goes to 0. So here, instead of theta, I have h. Okay, so now what we have found is the following formula, right? We found that the derivative with respect to x of sine x is equal to cosine x. Okay, was that? Yes. The derivative of sine x is equal to cosine x. Okay, this is exactly one of the reasons why, remember, in order to compute this derivative of sine, I used that limit number 1, right? In the limit number 1, if you look at the proof there, yeah, in this proof that we used for the limit number 1, right? We have used radian measure of theta. Without radian measure of theta, I couldn't have said what I said. I couldn't have said what I said there. Remember, I found the area of the sector. The way I found the area of the sector, I can only find it that way if I am using radian measure. And because I am using the radian measure there, now I got the derivative of sine x is cosine x. If I don't use radian measure for theta, there will be a constant factor right there, and it doesn't look nice anymore. That's why we're using radian measure. Okay. Okay. So that's the derivative of sine x. What's the derivative of cosine x? What's the derivative of cosine x? How would I find it? Well, it's in a similar way. You're going to compute the limit of cosine of x plus h minus cosine x over h. Cosine of x plus h, you're going to use the sum formula for cosine. Same thing happens. However, you're going to get negative sine x. So if you compute the derivative of cosine x by using the limit definition, you're going to get negative sine x. Is everybody okay? But I'm going to show you another way of finding the derivative of cosine x without using the limit. How? You guys remember this identity that I gave you? Cosine of x is the same as sine of pi over 2 minus x. Right? So then, because I have the chain rule now, what's the derivative of cosine x by the chain rule? What's the derivative of this guy? So you can think of this: outside is sine x, inside is this guy. So if you take the derivative of the outside, what do you get? So if you take the derivative now, you're going to get, so what's the derivative now? This would be derivative of sine x is cosine x, right? So, but you have to evaluate at the inside. You get this. And then multiply by the derivative of inside, right? What's the derivative of the inside? Negative 1. So what do I get? Negative. What is cosine of pi over 2 minus x? That's sine x, right? Remember, this formula that I have here, this also works for if I switch sine and cosine, that identity, right? So cosine of, see, sine of pi over 2 minus x is cosine x. Same way, cosine of pi over 2 minus x is sine x. So I could use those identities to come up with the derivative using the chain rule without going through the limit computation, okay? Anyway, but we have to do it for sine. Okay, we have to do it for sine. In any case, you have to memorize these two formulas. The derivative of sine, derivative of cosine. You just have to memorize them. Okay, how about the other trig functions? We don't have to compute any more limits to find the derivatives of the other trig functions, okay? So, somebody tell me, how would you find, we found the derivative of sine, we found the derivative of cosine. How would you find the derivative of tangent? Well, let's not look at tangent. How about we look at cosecant of x first? How would you find the derivative of cosecant of x? Anyone has any idea? Okay, so he's suggesting write this as 1 over sine x. We know cosecant is 1 over sine x. Okay, now what? You can use the quotient rule, but what I'm going to do, instead of using the quotient rule, I am going to write this as sine x to the power -1, and then apply the chain rule. So this would be what? What would be the derivative? Anyone by using the chain rule? Negative 1 derivative of sine x is cosine x, right? So again, here the outside function is x to the -1. So if you take the derivative of the outside, you get -1 x to the -2, but instead of x you put in the inside here, and then you multiply by the derivative of the inside, which we know is cosine, right? So what do I have then? I have -1 over sine x, sine squared x times cosine x, right? Can I do that? Now, the formula that you have here, it's okay, that's the derivative, we computed it, but it's not looking as nice. So let's just rewrite this as the following. We're going to rewrite this as 1 over sine x times cosine x divided by sine x. Can I do that? I'm just writing sine squared as sine x times sine x, right? If you agree with that, then 1 over sine x is what? Cosecant x. And what is cosine over sine? Cotangent of x. Is everybody okay? So what formula did I get then for the derivative of cosecant? The derivative of cosecant x is negative cosecant x cotangent x. Everybody's okay? Now, what do you think will be the derivative of secant x? How would you find the derivative of secant x? Yeah, except that it's just positive secant x. There is no negative tangent x. But your guess is very good. It's secant x tangent x without negative. Okay, so you can compute it exactly the similar way. You said cosecant x, write it as 1 over sine. In this case, you're going to write it as 1 over cosine. Once you write it as 1 over cosine, you can write it as cosine to the negative 1, then use the chain rule and so on. You're going to get this answer. Everybody's okay with that? So now I have 4 derivative formulas for you. 2 more left, right? 2 more left. What are they? Tangent and... So, you need that? Go up a little bit. Okay, so now how would you find the derivative of tangent? How would you find the derivative of tangent? You will write it as sine over cosine, right? And then what would you apply? You apply the quotient rule. So here's the derivative with respect to x. Actually, let me do it for cotangent of x, right? Cotangent of x would be the derivative of cosine x over sine x, and this is equal to what? Well, if I apply the quotient rule, I would be getting what? The square of the denominator, and then I have the denominator. What's the derivative of cosine? Negative sine minus cosine x times the derivative of sine, which is cosine x. Okay, what do I have? I have negative sine squared x, negative cosine squared x over sine squared x. What should I do now? I got the derivative, but I want to simplify as much as I can. Yeah. No. Okay. What I should be doing is, if I factor out the negative, I get sine squared x plus cosine squared x, and then what do I get? What did you get after that? Negative 1 over sine squared x, and what is that equal to? 1 over sine is what? Yep, negative cosecant squared x. Okay? So the formula that we obtained then is that the derivative with respect to x of cotangent of x is negative cosecant squared x. Okay, what would you guess for the derivative of tangent? What's the derivative of the tangent function? What did you say? Secant squared. Again, you do the same thing. You write tangent as sine over cosine, and then you apply the quotient rule, and you will get the same exact answer. Okay, secant squared of x. Okay, now we know the derivatives of all the trig functions, right? And do you have to memorize them? Sure, you have to memorize them. Okay. Yeah, go back up. Okay, so those are the derivatives of the trig functions. So now what I want to do is go over examples of computing derivatives. I forgot to give you a break, but you never asked for one, so you should have said something. I gave you the option at 11, right? You said a little bit later.
Yeah.
I'm going to let you go earlier. Let's say we're going to leave at 12:15 today. Okay. All right. So let me just go over some examples of using these formulas now. Okay. So first example. Let's say I need to find the derivative with respect to x of x squared multiplied by sine x. Okay, how would you find the derivative? How would you find this derivative? Yeah, so I have the factor x squared, I have the factor sine x. Product rule says you take the derivative of the first factor, which is 2x, multiply by the second factor, and then plus the first factor as it is, multiply by the derivative of the second factor, which is what? Cosine x. Okay, that's it for the... Oops. Sorry. That's the derivative. So this is another problem here. And I think I might have asked this question in one of the exams last time. d dx of secant x over 1 plus tangent x. What's the derivative of this function? Again, what should I do here? By the quotient rule, I have to square the denominator. So I get 1 plus tangent x whole squared. And then in the numerator I have 1 plus tangent x. That's the denominator. Multiply that by the derivative of the numerator. What's the derivative of secant? Secant
X,
tangent x minus secant x multiplied by the derivative of 1 plus tangent is? What's the derivative of 1 plus tangent x? Secant squared of x. Okay, and again, you can multiply out everything in the numerator and simplify it a little bit, but I won't do it. So that's the derivative in that case. Anyone has any questions on what I did there? Okay. Example. Suppose that y is sine squared x. What's the derivative in this case? What is the derivative in this case? Sine squared of x, when we write sine squared of x, what do we mean? We mean sine x to the power 2, right? Okay, so what's the derivative? It is the composition of two functions, right? What's the outside function? X squared. Inside function is sine x. So it'll be 2 times x, but it'll be 2 times sine x. Right, that's the derivative of the outside, and then multiply by the derivative of the inside, which is... Okay, anyone remembers what is 2 sine x cosine x? Is there a trig identity? Double angle formula? Sine 2x. This is sine 2x. Now, this simplification that I did here, yeah, if you don't do it, that's okay, but you really need to do it when you go to Calculus 2. You'll see that you have to do it. So it is a good practice always when you are in Calculus 1 to simplify your answers as much as you can so that you have the practice when you go to Calculus 2. Okay, let's make it a little bit harder. Let's say I have y is root cosine of x squared plus 1. Okay, what's going on here? Yeah, so you have to, first of all, I can think of this as the outside is x to the half, and then I have the inside is cosine of x squared plus 1. So I'm going to view it this way. So by the chain rule, if I look at the derivative of y with respect to x, chain rule says take the derivative of the outside, which is half times x to the half minus 1, right? But instead of x, what should I be putting there? Instead of x there, I should be putting in cosine of x squared plus 1, right? And then I multiply by what? By the derivative of the inside, which is cosine of x squared plus 1, right? By the chain rule, I take the derivative of the outside, evaluate it at the inside, multiplied by the derivative of the inside. Now, when I try to find the derivative of the inside, I have to apply the chain rule again. So I get half cosine of x squared plus 1 to the negative half times, here now what's the outside function here? The outside function is cosine x, inside is x squared plus 1, so what's the derivative? Derivative of cosine is negative sine of x squared plus 1 times derivative of x squared plus 1, which is 2x, right? I better put it in a parenthesis to make sure that it's not subtraction, okay? Is everybody okay with what I wrote? Now, if you can go from go directly to the last line, that's okay. Go ahead and do that. In fact, I encourage you to be able to practice enough that you could go from directly to the last line, okay? Everybody's okay with that? Again, if I ask you to find the derivative only, you don't have to simplify this, but when you go over your exercises at home, you should simplify your answers, okay? Especially, you should always when you do your exercises, you should always match your answer with the answers given in the back, okay? To make sure first of all, to make sure you did them correctly. Second of all, usually these are simplified answers, so you know how much you have to simplify. Is that okay? In the exam, I don't need you to do any more simplification. But again, just because I don't want you to doesn't mean you shouldn't have to, okay? You do it because there are other problems where you have to simplify the derivative, and of course, when you go to Calculus 2, there are many places where you have to simplify the derivative. Okay, in any case, let me go over one more example here. Let's say I have y is sine evaluated at, let me make it complicated, tangent evaluated at evaluated at x squared plus 1. Okay, it doesn't look so bad. Okay, so this is sine of tangent of root of x squared plus 1. What's the derivative in this case? What's the derivative in this? First of all, the outmost function is sine, right? So what's the derivative of that? Cosine. So you have cosine evaluated at the whole thing. Okay, tangent root of x squared plus 1. Then multiply that by the derivative of what? Derivative of this whole thing here, right? What's the derivative of that whole thing? Derivative of tangent is, so you get secant squared evaluated at x root of x squared plus 1, and then multiply that by the derivative of the root x squared plus 1. What's the derivative of the root x squared plus 1? Root of x squared plus 1 is the same as x squared plus 1 to the half, right? So what's the derivative? Half x squared plus 1 to the negative half, and then multiply by 2x. How many times did we have? Yeah.
The derivative of the secant squared x or the secant squared?
Derivative of tangent x is secant squared x. Is that the question you asked? Derivative of tangent of x is secant squared of x. Remember, sine, secant, tangent, without writing x or theta, they have no meaning, right? Okay, tangent of theta, the tangent of an angle, secant of an angle, right? Okay, did that make sense? If you could do a complicated chain rule application like this, it tells you that you know you can handle any other problems. Okay.
I've got to remember the.
Yeah, you have to remember the formulas for the derivatives for sure. Yes. All right. Okay, this would be the last example. I'll let you go after this. Let's say I have the function f of x given by secant squared evaluated at x squared plus x plus 1. Okay. So what is f prime of x? What is the f prime of? You notice that this function means what? This function means you have secant evaluated at x squared plus x plus 1, right? And then the whole thing is squared, right? That's what it means. So what's the derivative? What's the outside here? What's the outside function here? Outside is x squared, inside is what? Secant of x squared plus x plus 1, right? So then what's the derivative? Derivative of the outside is 2 times x, right? But you replace x by what? You replace x by secant of x squared plus x plus 1. And then you multiply by the derivative of secant of x squared plus 1, right? So what's the derivative of secant of x squared plus 1? What's the derivative of this guy? we want to find the derivative of this guy. So we know that derivative of secant x tangent x. So this would be, let me first of all erase that. Yeah, this would be secant of x squared plus x plus 1 tangent of x squared plus x plus 1, and then times what? 2x plus 1. Very good. Okay, you need to practice all the exercises that I'm going to assign, because a lot of the times in the exam it's very easy to make mistakes. So people would write secant x tangent x instead of writing secant of x squared plus x plus 1. Okay? And also right here, people would make mistakes right here. Sometimes people would even just say that this is equal to 2 times secant, and then they will take the derivative of this guy. They will say 2 times secant of 2x plus 1. Am I making sense? So make sure that you go over the exercises and match your answers from the back of the book, okay? Homework. We finished 2.4 and 2.5. All right, 2.4. 1 up to 15 odd. 1 up to 15 odd. Okay, problem number 21. Problem 39 up to 47 odd. (39) up to 47 odd. Did you get that? Okay. That's 2.4, yes. And 2.5. 2.5. Let's see. 7 up to 51 odd. 7 up to 51 on. And problem number 61. Problem number 61. Okay, that's it. Now, if you haven't started your homework on 2.1, 2.2, 2.3, well, now you have a lot of things to do in one night, okay? Tomorrow I'll be assigning probably at least two more sections.
When's the test?
Friday.
Friday?